Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Mr. Chika welcoming you to another video for Grade 11 Advanced. This video is especially for all my Grade 11 Advanced students who are going to give the Term 3 Math exam shortly. So here I am with a revision video for you on the FRQ Learning Objective 20 Mathematical Induction, where we will prove statements using mathematical induction. We are going to cover a lot of important questions from this topic, and please do watch the video till the end, because in the end I will be providing you the answer key for all the questions from Learning Objective 20 on mathematical induction. If you like this video, do consider subscribing. Like, share and subscribe to my channel, and also let me know in the comment section, was the video helpful for you? If you need any other topic, do let me know in the comment section. Let's get started with the video now on this learning objective. Next, we will be solving questions which are based on Learning Objective 20, which is the topic of mathematical induction. So I will be giving you here some steps that we are going to be following. In step 1, whatever mathematical statement is given to you, put the value n as 1 and check whether the statement is true or not. In the question that will come for your exam, generally it will be true. So you will verify that for n equal to 1, the mathematical statement given is true. Then you move to step 2, and here you are going to do the induction hypothesis. So here you are going to make an assumption. You will say, like, let the statement whatever is given in the question for the mathematical induction is true for some natural number k. So for k you will assume that it is true, you need not prove. And then for step 3 you will show the proof that the mathematical statement which is given in the question is true for the next number. So after k comes k plus 1. So if it is assuming to be true for k and you prove that it is coming true for k plus 1, the next number, then by the principle of mathematical induction you can conclude that the statement which is given is true. Okay, so I will be solving this question using the 3 steps I explained to you before. So step 1, we check for n equal to 1. So let n equal to 1, we put it in this mathematical statement. What is the mathematical statement? 8 to the power n minus 1 is divisible by 7. We have to check this. So let's put n equal to 1. Then 8 to the power n minus 1. Let's see what it becomes. 8 to the power 1 minus 1. So 8 minus 1 is 7. So definitely 7 is divisible by 7, which is itself. So every number is divisible by itself. Therefore, we know that the mathematical statement is true for n equal to 1. We have verified this. We have checked this. Now we are ready to move to step 2, where we make the induction hypothesis or we make the assumption. So let us assume, what is the mathematical statement? 8 to the power n minus 1 is divisible by 7 for n equal to k. So we are assuming for n equal to k this is true. We are not proving it. So now we move to step 3, and in this step we are going to prove. So what we need to prove? We need to prove for n equal to k plus 1, the next term, the mathematical statement 8k plus 1. So I'm replacing n with k plus 1. We have to check whether this is divisible by 7, and if this becomes divisible by 7, then we know that by the principle of mathematical induction it will become true. So we have to now check this. Now from the assumption, if 8 to the power n minus 1 is divisible by 7, so let me tell you, can we write 8 to the power n minus 1 as equal to 8k minus 1. What did I do? I just replace n with k. And from where I'm getting this? This I'm getting from step 2, where I make the assumption, this step. So I make the assumption that this is divisible by 7 for n equal to k. So I just replace. So if this is divisible by 7, can I say 8 to the power k minus 1 will be some multiple of 7 for some r? What does this mean? Let's see. So if a number is divisible by 7, what form it takes? For example, if I write all the numbers which are in the table of 7, can I say all of them are divisible by 7? right? Because 7 multiplied by 1 is a multiple of 7. Yes, it's divisible. 7 multiplied by 2 is 14, which is again a multiple of 7. 7 multiplied by 3 is again a multiple of 7. So all of these are multiples of 7. So any number which becomes divisible by 7 can be written in this form. So let's calculate value of 8k. I move 1 on the other side, so 7r plus 1. Let me mark this equation as 1. We are going to use this equation in order to prove step 3, where we have to show that 8k minus 1 is divisible by 7. So if I'm able to write 8k plus 1 minus 8 to the power k plus 1 minus 1 as some multiple of 7, we are done. So let's use this. Now we move to the next slide. Let's do and complete the proof for step 3. So continuing from step 3 from the last slide, we had got that 8k plus 1 minus 1. We have to check, is this divisible by 7? That's what we check. So let's take the left hand side, 8k plus 1 minus 1. Now can I write 8k plus 1 as 8k multiplied by 8? How do I get this? Because if I have to write 8k plus 1 means I break the power, so it is 8k multiplied with 8 to the power 1. So this is same as this thing. Now from step 1, what was our first equation? Uh, the equation we had got was 8k is equal to 7r plus 1. Okay, this was coming from step 2, so I'm going to put it here in place of 8k. Let's see what we get. So 8 multiplied with 7r plus 1 minus 1. Now we'll just open the brackets, do the multiplication. So this is 8 multiplied by 7r plus 8 minus 1. So 8 multiplied by 7r plus 7. We are just trying to simplify. Now let's see if we can take something common from here. Definitely 7 is in both the terms. So I take 7 outside, inside I'm left with this. So what do we get? 8k plus 1 minus 1 came out to be 7 times 8r plus 1. Now, if any number is a multiple of 7, can I say it will be of this form? This whole number is 7 multiplied with 8r plus 1 for some r. So can I say this whole thing is a multiple of 7? Yes. Therefore 8k minus 1 is a multiple of 7? Yes. Therefore 8k plus 1 minus 1 is divisible by 7. How does it become divisible by 7? Because it's a multiple of 7. So yes, our answer has been proved. It has been checked. For what value? For k plus 1. So if I'm able to check for k plus 1, conclusion, final answer is that by the principle of mathematical induction, the statement that 8n minus 1 is divisible by 7 is true. So this is what is your mathematical induction. Now I will show you the answer key for this question. This is the final answer key that I have taken for example 2 from your book. Here step 1 and step 2 is exactly same, but for step 3 they have used a little different method. If you like this method you can do it, but if you like my method you can also do it. Both are correct. It's all about proving that step 3 is true, and then by mathematical of principle of mathematical induction, completing the proof. Okay, moving on. Next question. So let's do one more question in a similar manner, similar to example 2, so that you become more confident. So I will be following the same method, same 3 steps. So step 1, let n equal to 1. Let's check. 7 to the power n minus 1. This is the mathematical statement. 7 to the power n minus 1 is divisible by 6 or no. We have to check for all natural numbers n. So if I put n as 1, this whole thing becomes 6, and definitely 6 is divisible by itself. Therefore, the mathematical statement becomes true for n equal to 1. So step 1 complete. Move to step 2. Here we will make the assumption. So let us assume this step is called mathematical induction hypothesis. So let us assume 7 to the power k minus 1 is divisible by 6. Now, this means I have taken the statement to be true for n equal to k without even proving. It's an assumption. I don't need to prove. And now I'm ready to go to step 3, where I'm going to check or prove whether this statement is true for n equal to k plus 1. If we are able to prove that, we are done. So before we check this, let me write the statement that we want to verify. We want to verify that 7k plus 1 equal to 1. This thing is divisible by 6. This is what we need to check. We are not sure. And what we know from this step, from step 2, we know that 7k minus 1 is divisible by 6. So it will be multiple of 6 for some r. So I can get value of 7k as 6r plus 1. Everything, if you see, is very similar to the previous question. In the previous question, just the numbers were different. So now I will check 7k plus 1 minus 1. Again, I will break this in two parts and I will replace 7k value from this step. Okay, so in place of 7k, I'm putting 6r plus 1. This value I'm replacing, and there's already a 7 multiplied, minus 1. Again, open the bracket, multiply 7 with 6. Let's multiply and just write 7 multiplied by 6. We are not multiplying it as such because in the next step we have to take common. Now 7 with 1 is 7 and minus 1. So 7 minus 1 is 6. So if you see, we have a term common which I can take outside. So 6 is here also. 6 is here also. Let's take 6 outside. So I'm left with 7r plus 1. Again, like the previous question, similarly, we can say that 7 to the power k plus 1 minus 1 is a multiple of 6 for some r. And the moment it becomes a multiple, we can say that 7 to the power k plus 1 minus 1 is divisible by 6, and hence for k plus 1 it is true. So final answer, by principle of mathematical induction, 7 to the power n minus 1 is divisible by 6. So this becomes true, hence proved. That completes the proof for this question. Let's solve one more question using principle of mathematical induction. So we first do step 1. So for step 1, we check for n equal to 1. So let n equal to 1, we put it in the mathematical induction statement. This is the statement. So let's see what we get. 9 to the power n minus 1. This thing, if I put n as 1, becomes 9 minus 1, which is 8. And 8 is divisible by 8. Every number, remember, is divisible by itself. Therefore, statement is true for n equal to 1. So step 1 is complete here. We move to step 2 where we do the assumption. So let us assume the statement is true for n equal to k. That means 9 to the power k minus 1 is divisible by 8. So it can be written as 8 times r. Or if I move the 1 on the other side, the value of 9k becomes 8r plus 1. Let's mark this number 1 and we are going to use this for the proof in step 3. So for step 3, we need to prove that the statement is true for n equal to k plus 1, the next term. That means we have to show that 9 to the power k plus 1 minus 1 is divisible by 8. This is what we need to check. So let's find this value. 9k plus 1 minus 1 can be written as 9k multiplied with 9 minus 1. So from here, I'm putting the value 8r plus 1 in place of 9k. And let's solve it by opening the bracket. So 9 multiplied with 8r plus 9 minus 1. 9 minus 1 is 8. So I can take 8 outside and I'm left with 8 times 9r minus 1. So this thing, 8 multiplied with 9 and minus 9r plus 1 is a multiple of 8. Therefore, this thing, 9k plus 1 minus 1 that we started, which is equal to this thing, is also a multiple of 8. Therefore, we can show that 9k plus 1 minus 1 becomes divisible by 8. So by the principle of mathematical induction, this question is proved. Okay, now question 18 we have already solved. So let's do one last question on mathematical induction. Here the statement given to you is 5 to the power n plus 3 is divisible by 4. So let's check. We start with the same method. Step 1, let us take n as 1 and check are both the sides equal or no. So 5 to the power n plus 3. I'm going to find its value. 5 to the power 1 plus 3. So 5 plus 3 is 8, and definitely 8 is divisible by 4 because 8 divided by 4 is 2. So it is true for n equal to 1. We have checked, and now let's begin step 2. Let us assume 5 to the power k plus 3 is divisible by 4. So if it is divisible, definitely it becomes a multiple. So I can write 5k plus 3 is equal to some 4r. Okay, this is the value. So from here 5k will become 4r minus 3. That's our first statement. I'm going to mark this statement, and for step 3 I'm going to use this statement for the proof. So in step 3 we have to check for n equal to k plus 1. So let's take this term 5 to the power k plus 1 plus 3. I can write this again as 5k times 5 plus 3. So I'm going to replace the value of 5k from here. So let's write 5 times 4r minus 3, and there's a plus 3 outside. Now we are going to do distributive property, open the bracket. So this becomes 4 times 5r minus 15 plus 3. 15 um, has negative sign because 5 multiplied with negative 3, and this 3 combines, so we get 4 times 5r minus 12. Now 4 and 12 have common term as 4, so I can take it outside. So 4 times 5r minus 3, this is the value that becomes equal to 5k plus 1 plus 3. So this is definitely a multiple of 4 because it is 4 multiplied with something. So therefore it is proved for n equal to k plus 1 that 5 to the power k plus 1 plus 3 is divisible by 4. Hence the proof is complete by the principle of mathematical induction. So here if you check, I have provided you the answer key. Just to give you more practice and make you more confident in solving questions of mathematical induction, I have put 2 more extra questions. Here in question 19, you had to show 12 to the power n plus 10 is divisible by 11. This is the solution in a similar way. And for question 20, 3 to the power n plus 11 is divisible by 12. This is the steps. Remember, for principle of mathematical induction, it will be FRQ. You need to show all the 3 steps nicely and give the proof to get full marks.